to my session, and I would like to start to say thank you. Thank you everyone for coming to my session, and thank you everyone for choosing me, because we have a lot of competitor session right now, at least 5 as I remember. It's my pleasure to talk to you. So thank you for coming, and thank you for showing your willingness to learn how to refactor your application to Reactive with Sprint 5. Since we are in Latvia, in Riga, I guess this talk name should sound like Refactor Pia Reaget. Is it correct pronunciation of the title, by the way? No, it's incorrect. Okay, sorry for that. I tried, I did my best to create some correct translation for the session. Nevertheless, I would like to start with asking you, and I would like to encourage you to take your phone, right now, take your phone, open your browser, and enter following website link, or just scan this QR code, and then you will see chat room. That's Gitter chat room, and the most active user and the most active chatter in that chat room will win the following prize. So just do it, enter that link, sign in the chat room, and start chatting. That will help me during the session, and that helps you to win that prize. Also, while you're doing that, I will shortly introduce myself. My name is Oleh. I am from Ukraine, from Kyiv, and I am software engineer, mostly focused on distributed and cloud system development. Along with that, I am active speaker, and I'm preaching reactive technology, reactive programming, and reactive system. And I'm preaching Reactor. And also, I'm open source committer to that project. And how many people use Reactor in their project? Just raise your hand. 1, 2, 3. Cool. I love you guys. So if you have some question regarding Reactor, and if you faced some issues during your work, you're welcome to ask some question, and I will do my best to help you and resolve your problems. Also, I do my best to improve my local community, my Ukrainian community, by taking a part as a program committee in such big conference like GEConf, Devox Ukraine, and doing my best with helping in organizing Java user group, local Java user group meetups. So it's shortly about me and what we are going to do today. First of all, we will refactoring during the whole session. But first, before starting refactoring, we have to learn what we have to refactor. And our source of refactoring will be non-reactive application. That's amazing source, which will be refactored in the end to reactive one. And our mission for today will be achieving something depicted on that schema. By the way, how many people knows what that schema means? Just raise your hand. 1, 2, 3, 4. For those who don't know what this schema means, it's Reactive Manifesto. And Reactive Manifesto describes the fundamental principles for building reactive system. And we will build reactive system in the end, and our reactive system will look like that in the end. Like the whole stream of messages, natural stream of asynchronous non-blocking events, from the source to the very end. But that will be in the end, and now non-reactive chat application, and chat application as a domain for our today refactoring. So this chat application has really simple functionality. First of all, we will take our messages for our chat application from the Gitter. How many people knows what is Gitter and has some experience with Gitter? Few hands. For those who don't know what is Gitter, Gitter is chat application similar to HipChat, to Slack, to whatever chat, but Gitter mostly focuses on GitHub. And Gitter loves GitHub, and Gitter allows you easily build your chat room around your GitHub open source project. Along with that, we will provide some additional functionality, which is message statistic or calculation, the most active user in that chat room, and the most mentioned user in that chat room. So again, I remind you that the most active user in that chat room will be able to win this watch. So let me show that application first to ensure that that is what I said is our functionality. Here is our application. Oh, we have the most active users here, as you may see, someone in this room. And here is the main functionality, which is showing the messages. This is our application, nothing special in there. And the most interesting right now is getting some understanding of what is going on behind the scene. First of all, I would like to start with describing the toolkit or toolset in our application. Here we use really simple Spring Framework, Spring Framework 4. How many people use Spring Framework in the development? Oh, amazing. A lot of people use Spring Framework in the development. Cool. To build some client-server communication and to build web application, here we use Spring MVC. How many people use Spring MVC in the development? Yeah, I have an amazing team. And for wiring communication with database, we use Spring Data. And our database for today's session will be MongoDB, since we use Spring Data MongoDB. And finally, to run our application smoothly, we use Spring Boot. This really simple, I guess, common everyday stack. And along with that, we have really plain architecture as well. We have three main components in our system. First one is a client or browser. The second one is the source of the messages or external system, which is Gitter. And the central one is our application, Spring Boot application. Spring Boot application has three main parts. First one is a controller layers. The second one is a business logic layer or service logic. And the third one is persistent layer. So really plain three-tiered architecture, right? And let me show it to ensure that this application is like that. So here is our application. Here we have controller layer with some controllers. Here we have service layer with interfaces, some business logic in there. And here we have repositories and objects that represent the structure of our database. So this is really plain architecture, as you may see, and this is really common architecture for building microservices today. Along with that, we have some execution flow and some business logic for retrieving messages. And current business logic and flow looks like following. We enter the page. We have to collect some first list of messages from Gitter. We do that, and we have to wait because it's blocking call. Of course, we have to wait a bit, and then we receive somewhere or someone at some point of time response. Then we have to store received messages. Because we have database, of course, we have to store something in there. And then right after updating the messages, we have to recalculate statistic and update statistic based on the stored messages. So after doing so, we will be able to send final response to the user and render the first page on the screen. Along with that, we have really small JavaScript in there, which does with some interval absolutely the same calling to our server. So there is some pooling mechanism for checking whether there is some new messages, and it goes through the same path. Absolutely the same execution flow. So let me show it again. Let me explain some business logic in my application first. So here, there is the first entry point. Here we have the main controller or index controller. Here we execute the first request to the Gitter service. After receiving the response, we store all the messages inside the database or inside statistics service, which looks like following. So we store messages in the repositories, and then after storing messages in the repositories, update statistic and find the most popular user in there. After doing so, we collect all the data in the model and respond back to the user with some UI. The UI looks really, really simple. I'll show you. Here we have some HTML in there with some UI, etc., etc. But the main logic is hidden here. The main pooling mechanism is hidden here. Here we have some interval which allow us with interval repeat the action, repeat the pooling. And here we have some execution call to REST endpoint and our logic of processing messages. Here is our REST endpoint, really simple REST endpoint. We have get mapping, and we define some, since we have to manage we have to rely on some state, which is sent by the client, which is the cursor or the ID of the latest messages. We have to rely on that state, and we have to pull new messages based on the latest message ID. So here we do almost the same. We call for the latest messages, which is really simple functionality. It's REST template, nothing more. We call for new messages. Right after that, update statistic again, and return the response. That's our flow from the code perspective. All right. Now let's go back to our slides, and let's summarize. In general, we have really plain Spring application, almost everyday Spring application, Spring Boot application. Along with that, we have plain three-tier architecture in our design, and we have really common interaction flow. Finally, this application just works. So what's wrong with that? Why I'm talking about that application? From my perspective, there is some three main problems in that application. First one is pooling model. And pooling model might be compared to the following. The checking other new messages, new messages.
Mama! What? Hi.
There might be no new messages, at least. But I guess you may disagree with me, because that's really common pattern for checking for new messages and updating something in real time, almost real time. But the problem here, in case if we have a lot of clients, that pooling will look like following. And that's the problem. And the second one is blocking I/O, which is the pure evil and the pure wasting of the resources. Because instead of sending request and then react to response, we send the request and block. And block, wait for response, and then return response. And that's another wasting of the resources. And finally, our application has some gaps. It's unresponsive. And that's really a huge problem, because in case if I turn off my database to simulate outage of external services, so now I turn off the database and try to reload my UI, you will see that nothing will be displayed. Our application will hang. Even if I try to do so a few times, we will see that our application will be crashed. And that's another problem, which is unacceptable. And that's impact overall user experience, and that's bad. So we have a list of problems, and now the main question, how we may fix it. And to fix it, we have to change our mindset or rethink our overall design. First of all, we have to react. We have to be reactive. We have to react to responses. Along with that, instead of pooling, instead of checking whether there is new messages, we have to react on changes from external services. So we have to have push API instead of pull API and pull design. And finally, we have to be reactive to failures, or we have to be resilient. And to achieve resilience, we have to isolate our components from external services. And now, the main question, how to be reactive, or how to achieve that? And the answer is really simple. By migrating to new reactive Spring, and especially new Spring Web Flux, which is almost similar to Spring Web MVC. First of all, let's recap what is Spring Web MVC. Spring Web MVC is a really common stack which has on top annotation-based programming model, which is powered by Spring MVC project, which is built on top of servlet API and executed by one of the servlet containers like Tomcat, like WebSphere, or whatever servlet-based server. In turn, Spring Web Flux almost similar. It has the same programming model, the same controllers, and the same annotation, but under the hood it is powered by new Spring Web Flux and built on top of asynchronous non-blocking communication with the network and executed by one of the servlet servers, servlet 3.1 based servers, on really powerful Nettie or Undertow servers. The core library in new Spring Web Flux is Project Reactor, and Project Reactor allows us writing code like this, which looks like imperative code. In fact, it's asynchronous non-blocking passing of the events. And if you know servlet, if you know Stream API from Java 8, by the way, how many people use Stream API from Java 8? Oh, almost the whole audience. And those who knows how to use Stream API will be able to write similar code. In addition, all you have to know about Reactor is two reactive types. First one is mono, which allows us asynchronously non-blocking process 1 or 0 elements. And the second reactive types is flux, which allow us processing collection of the events or infinitive amount of events in the stream. In turn, all this reactive type is built on top of one interface called publisher. So if you see that interface, don't worry, just remember that that's related to reactive programming and reactivity at all. So let's do it. Let's now move our application to new reactive project and new reactive web flux. And now I will show you. Before we start coding something, I would like to say that I'm really lazy developer. And I guess you are really lazy audience and you don't like to see the each later that I will type in my notebook and my laptop. And instead of typing and doing so, I will switch between commits. It's like we will run separate sprints as in the usual development, and we will start sprint and then jump into the end of the sprint and analyze what has been changed during the sprint. All right? Good. Let's do it. Let's jump to the end of the sprint and let's analyze the changes. First of all, let me restart that application while we analyze what is going on in there. And here is our changes. First change is migrating from Spring Boot 1 to Spring Boot 2. That's absolutely required changes because new reactive fancy stuff is available only with Spring Boot 2. You have to remember that. And the second change here is providing additional model called Spring Web Flux. So along with that, with old good Spring Boot Starter Web, we provided here Spring Boot Web Flux. Also, of course, we have some changes in API, and one of the changes here is changes in Spring Data API, so we have to check to fix our compilation error in old code and provide some save all instead of save. That's all changes that we have to apply here. Also, I will run my database again to show that with those changes our application will work. And yeah, here we are. Our application is working, and if I write some messages here, right now I'm doing so. Where is the chat? Here is the chat. Come on. Yeah. Yeah. Here we have some messages in there. So it works. Now it has some reactive dependencies, and it seems like, what else should we do? Let's do some summarize, let's do some retrospective and analyze what we have to do to be reactive. First of all, we have to move to new Spring Web Flux. Along with that, Spring Web Flux brings with it new Reactor project, which allows us building reactive asynchronous code, and it's new programming model. Also, with migration to new reactive dependencies, we have to change just a few lines of code, which is amazing. And finally, we have to fix only few compilation errors, which means that Sprint developers team did their best to provide for us smooth migration to new Spring Boot 2 and new Spring 5 and reactive Spring. That's cool, but that's not enough to be reactive. To be reactive, we have to change our whole system and refactor our system from end to end. You should remember, you might remember that, as I mentioned at the beginning, we have to move from pull-in model to push model. We have isolate our component, and we have to be reactive. And that's a lot of changes. And that's unacceptable from business because we will spend few or 2 or 3 sprints on refactoring just one service. So instead of refactoring our application or simply rewriting the whole application from scratch, we will try to change step by step our code and doing real refactoring. And from my perspective, the most important changes is changes in communication between client and server. And first of all, the first step of refactoring should be refactoring of the API. So let's remind what is going on in our communication between client and server. First of all, we have REST architecture in our server. So we have REST API, and REST means stateless. So we don't have any state in our server. Instead of that, the state is held by the clients. All clients and every client held its own cursor ID or the ID of the latest message here. And we start calling to the API, it sends almost a similar request and receive almost the similar responses and update their state based on received responses. And the state will be almost similar. And the problem here that all requests are almost similar and all requests are redundant. So instead of requesting redundant additional messages and doing similar job and repeat yourself each time, we will move first of all state from client to server. And we will provide pooling mechanism on the server, and we will hold all the state on the server side. And in communication between client and server, we provide static or stateful connection between client and server server will be responsible for populating or multiplexing all new messages between all clients. That's what we will do, and that's actually a challenge, at least few challenges, even more. The first challenge is providing server-side push or push API between our client and server. The second challenge is management of subscriber, because each client, each open browser is new subscriber, and we have to manage all them and send all messages between every open browser. And the final challenge is implementing own server-side push mechanism. So how we may do that? The first answer is we may rely on server-send events. By the way, how many people are familiar with that push API, that technique? Oh, few hands. Cool. The server-send events is a standardized way from HTML5 to create push communication or static stateful connection between server and client over HTTP. So we will use that technique, and you will see that providing such stateful connection or static connection, continuous connection is really simple. In turn, we will use some mechanism from Reactor library, which is called reply processor. And reply processor allows us easily multiplexing events between all subscribed users or between all subscribed clients or browsers. In turn, it provides some additional functionality like dynamic caching. And now we will be able to easily introduce caching in our system. And finally, with usage of combination of Reactor operators, we will be able to build efficient pooling mechanism on the server side. So let's do it. No more words. Let's start our new sprint, and let's provide these changes in our system. Again, jumping to the end of the sprint, applying all the changes. While I'm talking, I'll restart the application, and yeah, it's restarting. Cool. And now let's analyze the changes. As you may see, there is only 3 classes which has been changed. The first one each chat controller as index controller, and we remove redundant call for each subscribed client. So now we just return HTML and that's it. The second change is change on the client side or changes in the rendered HTML. And here, as you may see, just two differences in the code. Instead of pulling, as we did it earlier, we use some HTML5 JavaScript API, call it event source, and we connect to the server and then react to all received messages as we did earlier. That's it. That all changes. And finally, on the server side, we have a bit more changes, of course, but from the communication perspective, we're still using the same get mapping, the same annotation for built-in controllers. But we provide additional text event stream type, which explicitly define that this will be continuous streaming connection, and all messages will be streamed using Flux, and again, Flux is infinitive stream of messages. Here we use some merge technique from operator to merge two stream of messages, like messages from pull-in requests for messages and change its statistic. So here we merge two streams, and finally, pull-in mechanism, which was before, still the similar as earlier. So we provide some additional technique for providing manually messages to the stream and provide manually changes of the state. So let me introduce it shortly. Here we have reply processor, and here is a technique from processor called syncs, which allows us manually provide messages inside the stream. And here, let me switch to the full screen first. And here we have some reply processor for storing the state or storing the current cursor ID. And here we have some manual supplying of the first cursor. And here we have some code from Reactor. I guess it's unclear for now. It's not transparent and it's not simple as it seems. But first of all, I would like to show you that our application is working. And that's it. So I'll restart my application. Come on. Network, just work. Come on. Yeah, here we are. Here we see some messages. You may chat actively. I will help you. Come on. Yeah, here we see some messages on screen, and that's cool. It works. In turn, let me explain what is going on in some better way. Here is the code that we wrote during our sprint. And first of all, when we manually supply the first state, it will be moved to delay element. And delay element does what is like it sounds. So the first element will be delayed, and the second, as operator, will receive delayed element after the first second. Then we will execute the same pooling mechanism. We will start fishing for new data, and eventually we will fish new data and send it to our processors manually again using Flux, using message sync and using statistic sync. Right after that, we will update asynchronously and nonblockingly the latest message ID and send to ourselves again and execute the same process with delay again in the cycle. For example, let's suppose that there will be some outage of the database or outage of the external Gitter service. In that case, we start pulling messages again, but in that case, we will fail. And in previous case, with failure, our application become crushed. But in that case, with the usage of Reactor API, just with the usage of one line of code, we will be able to restart our pooling again and eventually success and fish new fish and get new data from the external services. And I will show you that this is like that. For example, let's turn off our database again. Let's turn the network and let's restart application. And our application is still working. Okay, we are disconnected from the network That's fine. We can't depict we can't show new messages. We can't receive new messages. But right after we turn on our network, let's ensure that we connect to my phone, to my local network. Come on. Right after we start our database, we connected to the network, we will immediately start receiving new messages. Yeah, it works. Someone mentioned that it doesn't work. It worked. So, as you see, we recovered from the failure without impacting the final users, which is amazing. I love it. And what is going on behind the scene? First of all, by using the processor, come on, that's the old animation. By using the processor, we are able to isolate our final users from our pooling mechanism. And each connected user will always be able to receive latest cached messages. And this cache, again, it's the dynamic cache. So all changes in that cache will be pushed to final user again with new messages. And let's do some recap and let's do some summary of what we did, because it's important to verify and to do some retrospective after the end of the sprint. So first of all, by moving our pooling mechanism from client side to server side, we enabled some optimization, implicitly improved our optimization and resource usage. In turn, we got out-of-the-box caching just by using some API and some cool feature from Reactor. And in addition, by using the same feature, we were able to provide some multiplexing and storing all subscriber user inside the Reactor classes. Finally, we improved significantly the responsiveness of our system, right? We saw that even if some parts, some external services is unreachable, we are able to return the response to the user, which is really, really important in any system. All right, that's cool. We provide some changes, but that's not enough, because we still have blocking operations. And we have to remove all blocking, and we have to move to totally non-blocking communication with external services. That's another challenge, and the challenge is achieving end-to-end asynchronous and non-blocking communication between all the internal components and all external components. And how we may solve it? First of all, we have changed our interaction between components, or our structure, or our interface. First of all, we have moved our synchronous imperative communication response type or parameter type from object, for example, to mono of object. We have to use reactive communication, reactive types. In order to provide some stream or collection of changes, asynchronously, non-blockingly, we have to move from iterable or collections to flux or stream of messages. There is some exclusion from that rule. For example, when we move from pull mechanism to push mechanism, we have to change from one imperative type to the stream of those imperative types. And let's do that. But before we do something, we have to remember that along with internal communication, we have some communication with external components like database. And this database, we usually provide communication over repositories. For example, like CRUD repository. And CRUD repository should be changed to reactive CRUD repository. It's additional feature from new reactive Spring. And if we look in the internals of reactive CRUD repository, we will see that this repository is almost similar to the previous one, but the only difference is it relies on reactive asynchronous non-blocking communication. In turn, for communication with external services, we usually use REST template. How many people use REST template for wiring communication with external services? Oh, that's better. All we use REST template for wiring communication with external services. New Spring Web Flux provide us new replacement for old REST template, and that replacement is called Web Client. And Web Client looks like that, but the most important that, again, all communication is based on the synchronous non-blocking types. So right now, we know how to implement new features, how to implement asynchronous non-blocking communication. Zeus, let's do that again. Let's jump to the end of the sprint again. That's another sprint. And here we have much more changes than in the previous one. First of all, we have to provide new dependency. We have to replace old sprint data mono dependency to new sprint data mono reactive dependency. That's one of the changes. These changes allow us using new reactive CRUD repository, especially new repository called reactive mono repository. And here we have only 2 changes in our class in order to achieve asynchronous and non-blocking communication. Also, in our code, we have more complex querying for the latest, for the latest messages. We have some custom query to MongoDB to find the most active user and to find the most popular. And even if we have some complex mechanism, all we have to do just changing, first of all, synchronous Mongo operation to reactive Mongo operation. And along with that, we have to change synchronous response type to synchronous non-blocking response type. And that's it. Also, we have to rewrite a bit of code with communication with external services like that. Here we replace it all good REST template and the logic related to the usage of REST template with the logic related to the usage of new web client. And here is our new web client. And here is some new logic with which we have to be familiar. But that's another story. Let's just keep it as is. Also here we have some changes in the communication with database, again, moving from imperative to reactive. And finally, in the REST controller, we have some changes in our flow, because we have to move from imperative programming to new reactive programming model, which is available with new Reactor 3. First of all, we have to receive some stream of messages. We have to isolate some communication again. We have to do the similar for storing the data. And since we are coupled with statistic and with calling for new messages, we have to update the cursor ID only right after the changes has been stored in the database, and we have received the latest statistic. All right. To ensure that this application now is asynchronous non-blocking, I will do following. I will provide only one thread in my Tomcat application. Currently, we rely on Tomcat, so I will set the max thread count for my Tomcat to 1. So we have only one thread to handle all possible requests. So let's restart that. Let's restart our application. Come on, let's do it. Just work, yeah. Here it works. Here we're running our application. And now I will open new window. And what I will do, I will split those windows together. And you will see. Yeah, here we have some working. Come on, what's wrong with that? Maybe something wrong with my network. Let's check it. No, it works. Something went wrong. Demo effect, as usual. Come on. Come on. Everything has been crashed. Let me restart my application again. Okay, while we are waiting, let's summarize. Let's do some retrospective while our server restarting again. So let's check. Let's summarize our changes. First of all, we improved resource utilization again. We push it almost to the limit, because now all communication with external services are asynchronous and non-blocking. In turn, we got reactive end-to-end reactive application. And finally, the migration to new asynchronous non-blocking communication is really smooth. We don't have to change a lot in our application. And again, let's check our system. It has been started. And let's reload it. Shit. I have no idea what is going on here. Let me restart it again. Come on, I hope it will work that time. Come on, come on, come on. Ah, it doesn't work. That's demo effect. All right. Let me reconnect to the network again. Maybe something wrong with the network. I don't like that situation. That's wrong Wi-Fi. I'm nervous of course. So our application has crashed, so let's move further. We have no choice. Okay, final migration and final refactoring of our application is moving from pull-in model to push model. And that's the final changes and the most important changes. So what we may do in order to achieve push model instead of pull? Fortunately, Gitter provides us with push API. So we may call that push API, provide continuous connection between Gitter and our server and react to all the changes on the server, all the messages that came from Gitter, and then push it to our UI. While we are doing so, I will check again. The final try and the final restart again, because I want to show you that new amazing changes here. Come on. No. That's bad. Okay, let's move to the next step, which is push mechanism. So let's apply the changes. I hope this time our server will be available and will be able to handle all the requests. Let's start the server, hope for success. And no. Okay, let's stop the database and start it again. Maybe something wrong with the database. Yeah, great. We have a working application, which is amazing. That's success. That's a small success. So at least my presentation won't be failed at all. So that's a success. And let's now analyze the changes in there. First of all, to achieve push model, we provide some additional communication with Gitter here. As you may see, we provided additional method called getMessagesStream. And we use the same web client for achieving new messages. But in the previous case, we received the mono of the collection, the mono of the latest messages. And in that case, we received the flux, which means that now we will receive the stream of the messages. Also, we have changed it a bit, our REST controller here. Not there, but here. We have changed our flow. First of all, we have two streams of messages. One stream with the latest list of the messages, which we will retrieve at the very start of the application. And the second one is the continuous stream of the messages. Here we separate all these messages on two separate streams, and by doing so, we explicitly separate and isolate our statistic component with our streaming messages to the client. And finally, if we will look at what is going on behind the scene, we will see that code, that's the most important part. And by running that code, we will build following execution model and following execution tree. By connecting to Gitter service, we will be able to receive first list of latest messages, which will be published immediately to all subscribers. Right after that, that connection will be disconnected, and then after some time, we will be able to receive some messages in the continuous stream. On the other hand, on the other side of our application, we will stream those messages between our client, between our subscribed clients, and without waiting on the changes for the changes in the statistic, in the database, in the external database, we'll be able to asynchronously update all new statistic. So let me show it. Let me show it again. So our application works, and just by stopping database, we'll be able to receive messages even if something went wrong with our database. Do you see that? Do you see that? Right now, the statistic is not changing, but right after running database again, all messages will be automatically resent to the database and will be stored in our MongoDB. All right. That's cool. That's our flow, but if we look on our system right now from the bird view, we will see that now we achieved the system, the application that we wanted at the very beginning. So now we receive messages from the very beginning, from the stream, from our source of the messages, and send it through the whole system to the very end and to our subscribed clients. Finally, we may improve our application even more. The guys on the back during the whole session analyzed new features of new Spring Web Flux and found that we may remove our dependency on Tomcat and move to new powerful server, which is called Nettie. And Nettie is a synchronous event-driven framework and server. What's cool with Nettie? Why it's better than Tomcat? First of all, Nettie is built on top of asynchronous non-blocking communication from scratch. In turn, in the core of the Nettie, there is event loop. And that allows us achieving really super high throughput and low latency system with really high performance. In turn, it allows us push our utilization and resource usage to the maximum. So our system will utilize our resource super high. If we compare our Nettie to Tomcat, we will see that one Nettie may replace two Tomcat. And by replacing all our Tomcat-based infrastructure to Nettie, we will be able to reduce the cost on the infrastructure by 2 times, which is really amazing. We may save the money for our business. That's really important. So let's apply Nettie server. Let's do the final changes in our system. And all we have to do is remove the old dependency on Spring Boot Web. Because Spring Boot Web explicitly say to Spring Boot that the main server is Tomcat. And by removing Spring Boot Web and keeping only Spring Boot Web Flux, we will say that now default server is Nettie. So after restarting our application again, let's do it. Our application is restarting. Come on. We will see that now the main server is Nettie. Do you see that? Nettie. Now our application is running on top of Nettie. That's it. Let's do the final check of all the sprints for migration from non-reactive to reactive. And let's check our application toward Reactive Manifesto and check whether it corresponds all the fundamental principles. First of all, our application is resilient because our application is able to react on all external changes and all failures, and regardless, send the main value to our clients and our subscribers. In turn, by relying on new Reactor, we are able to be asynchronous non-blocking, which means in some degree message-driven. And finally, just by applying the 2 fundamental principles, we will be able to be responsive. Regardless the outage of the database, regardless the outage of the network, we are always able to send some messages on the screen and be on some degree responsive. That's really important. One point that is missing, that is left unclear, is elasticity. And elasticity means ability to scale our application and react to changes on the demand and expand our application and then collapse when demand has been changed and has been decreased. And that's another story, but one more thing I would like to add here, we may achieve elasticity just by applying Spring Cloud streams. And we will be able to split our application, our small system, on two separate independent components and run it into the cloud, and scale it independently. But again, that's another story. And now let's take away something from that presentation. First of all, asynchronous non-blocking is for Reactor, and you may achieve that by using Project Reactor. Also, by using reply processor, you will be able to easily multiplex and dynamically cache data and messages. Also, if you would like to achieve resilience and isolation, just use timeout and retry and one of those retry operators. Also, in order to migrate your application from imperative synchronous and blocking to non-blocking and asynchronous, just move your imperative type to reactive types. Also, you have to move your communication with external database from CRUD repository to reactive CRUD repository. For external communication, move REST template to web client, and of course, move your web communication with Spring Web MVC to Spring Web Flux. Finally, move your Tomcat server to Nettie and achieve the really performance and high performance application. Also, I would like to talk and provide some insights about disadvantages of that technique. First of all, it's hard to understand. It requires some additional learning and some additional digging in the source code, in the documentation, etc., etc. Along with that, sometimes we have to rewrite code from scratch, like in case of moving from REST template to web client. Another point is JDBC driver, and JDBC driver unfortunately blocking. Fortunately, Oracle is working on that, but I'm not sure that we will get that feature in the few closest years. Finally, debugging is another challenge, but instead of debugging, I recommend you to test and verify your application using step verifier, which is part of Reactor. Along with that, we have a huge amount of advantages. First of all, the main advantages is Reactive System, and we may easily achieve Reactive System with Spring Framework, and the same Reactive Spring Framework means the same framework with all features that we love. Also, by moving to new reactive way, we will be able to improve our performance by 2 or 3 times, and we will be able to efficiently utilize our infrastructure and our hardware. That's really important. Also, if you're curious about reactivity, I recommend you to read following books. First book is Why Reactive? And that book expands why we have to use reactive and why reactive is so important in nowadays. Along with that, I recommend you to play with WebFlux. And there is an amazing workshop from guys from Spring Framework which allows you to play with Spring Framework and learn how it works under the hood. And you have to remember that Reactor is the core of Spring WebFlux. That's why it's important to learn how new Reactor works and what operators do we have in there. Finally, you may build your production-ready server without any additional problems. And you may learn how to do it correctly by following the stories of failure and success from Netflix.